Hello everybody, my name is Yoni, I'm from team GreenRating, and these are my team members, Nathaniel and Niv. And together we've built a reputation system for e-commerce in places where reputation systems for e-commerce do not exist, namely when trading something that people don't want you to trade. When we were building this product, we were inspired by the recent happenings to Telegrass, the infamous drug trading Telegram group, which was shut down earlier this year, and its founder, Amos, was arrested. And when we were first thinking about it, we said, there is no way that something like that does not exist. And after a bit of Googling, we found out that there are a bunch of solutions for decentralized e-commerce stores, for example, Open Bazaar. And the problem is with all those solutions is that they are full of scams. This is from today, from Reddit. I just went to the Open Bazaar Reddit, and the first post is somebody got scammed when they were trying to buy cannabis. So what we decided to focus on is build a reputation system. We were inspired, after talking to some of the judges and some other people, by the PGP Web of Trust. So we essentially decided to create a cascading chain of signatures. We used simple RSA keys, but any sort of public-private key system can be used as well. The way we built it is we have a node running on the system that's presenting an API to a web client, but this is flexible and can be bundled together in any number of ways. And I think the next step is to show you the demo. Go to the next step. Nice. So, I hope that everybody can see. I hope that everybody can see the beautiful design we have here. I'm not a designer. You log into the system, you have sort of a safety rating you can configure, and that safety rating determines how far away in the web of trust your trusted dealers are. So if I look at all the dealers, I see that some of them are approved and some of them are not approved. And this is determined based on how safe, I'm trying to do it with my finger, how safe I want the system to be. So essentially, how many people separate between me and the dealer. There's also a bunch of functionality around it, of course, adding new dealers, approving new dealers, and adding sort of thirst sources we trust. We've implemented all three of those. Two of them are actually identical. The next steps for development are implementing blacklist functionality, which gives negative scores to some of the dealers, as well as a peer-to-peer communication system, something similar to how people discover peers on BitTorrent, to share those lists in a robust manner. So I think that's, you can play with it if you want. That gives like a rough description of the system, and I'm happy to take questions.
Okay, thank you. So you mentioned the peer-to-peer network. Is that something that's working now, or something that?
So the peer-to-peer discovery is something we haven't focused on now. We're just the client for validating and displaying the web of trust.
Right, and how does key management work?
So right now the key is generated with a node. There's like a Python node that runs on my computer. It's on the person's computer. It can be written in any number of ways.
Right. So do you have a way to pick up your keys, or?
Not in this version, but they're exported to a file.
Trusted friend use digital signatures in the process?
Yes. So a trusted friend is, we have sort of like a definition for an entity in the system, which is a public key and a few other parameters. And adding a trusted friend is essentially signing this definition.
And does it verify the digital signatures?
Yes, it verifies the digital signatures when you use the add entity field. So the add entity adds an entity with signatures. It's all just text blobs where you can put in JSONs. It's not well formatted. In future versions, it will be just uploading files and exporting files, or just communicating directly with the clients. But in this one, it's just passing JSON text. It contains everything we need encoded in Hexa.
Any more questions? You have this on GitHub, right?
Yeah. The front end and the back end, two separate people.
One thing that would be nice is telling you, like, for dealers that are approved, the aspect between you and them, like which blend of your sign over them.
So we have that actually.
We have it in the back end. It's not like.
It's not visible in the UI?
Yeah, but you know, we have like the edges of the graph saved in the database, so it's front-end work to
Mostly a
display.
matter of time. If we had more time, we could have easily implemented a feature that shows you the shortest path.
What is the technological steps for this? Which database? Which?
Database, we're using TinyDB, but it could be, because we are using an ORM, it could be replaced with any document-based DB like Mongo. We're using Flask for our backend, and for our front-end, we're using React.
Can I ask you a question?
Yeah, sure, go ahead.
Is there a plausible reliability? Like how does it, so there's something interesting of having the graph of all the people that smoke weed and know who else likes to trust them. So is there abilities to, one, to revoke keys, and two, are there like symmetrical that you can say it's not me, he made it up, or things like that?
There is none of that fancy cryptography implemented in this version. Of course, in future versions, this could be done in any number of ways in which deniability is created today. I don't know, ring signatures, you think about whatever you want. Oh, it will be, yeah.
Your service goes away. Does the vendor keep the reputation?
Yes, so everything is stored on the client's, which can be the vendor of the consumer's own computer. That's sort of like the main point.
So it's like a central server that stores an index of everything? Like where is the list loaded from?
So in this proof of concept, we have not created the peer-to-peer network, but we imagine something similar to how how torrents are spread around. Just for drug dealers.
Okay, thank you very much.
Okay. Hi guys, we are a team of two, Aviv Cohen and myself, Adi Shimoni, and we want to solve a very simple problem that I was amazed that no one did it before, and to create a site that shows the fees in a very simple way in Hebrew, to save all the questions that we have in the community from time to time. Why is my transaction stuck? What is the right fee? And as we all know, there are sites that are doing that already, but they are much more complicated. And usually it's for engineers. And this is it. Okay, a simple landing page to show the transaction in Bitcoin. We can see it in Bitcoin, dollar, and in Israeli, in NIS, Israeli shekel. We did it for a basic transaction with one input and two outputs. We can add more advanced features, you know, but it will make it more complicated. And that's it. Actually, you can switch between Segwit and legacy. And we think that it can be useful for the community. Since it's very simple, nothing more to add.
All right. Questions? Yeah. Okay. So yeah, this looks very easy on the eyes. So where is this data coming from? How do you calculate the
Okay, actually, okay. So it's behind the scene. It's a .NET Core. It's a .NET Core. Okay, it's a .NET Core server behind, and it's a simple page. We're taking the fee from a site that using the Bitcoin. Since Bitcoin Core 16 version, there is an API call to calculate the fee. So it's used. We're not using our node because of the Hackathon. We're just using another site. Then we were using, I think, 3 or 4 APIs here. One to get the Bitcoin fee. One is to get the Bitcoin this dollar and the NIS. So actually, it's like we have a few API calls. That's it.
So is that the estimations from Bitcoin Core?
Yeah, it's the estimation. Actually, in the end, it's from the Bitcoin Core. So it shows something that I think it's usually very useful. We want to get fast into the blockchain, and maybe you want to minimum fee. But of course, it can be customized and actually. That's it.
Thank you.
Cool.
This looks very nice actually. Very
Yeah.
easy to see the data. This could be very useful on the emBassy on the stream. People
Yeah.
sometimes send transactions first, just need a way to glance and figure out how much they need to pay. One thing that I might add is maybe a 24-hour estimate, because sometimes you send and you don't find it sometimes. Waiting for a day is what people are used to from the banking system. So
Yeah. Okay.
you can usually pay next to nothing if you're going today for a day. And also the segwit switcher is a bit unclear. You would maybe do 2 buttons, like tabs or like legacy and segwit next to each other. And there are also 2 types of segwit.
Yeah.
Might also be a useful addition, but on the other end, also keeping it simple.
Yeah, so I think we need to do, I think that it can be useful, as you said, to put it on one of our community sites. emBassy it's a good idea. We need to add an English page. It was not so relevant to this hackathon, but I think. And also what? Yeah, it's also with the advanced. I think we can add, to choose the script type and the number of outputs, but it can miss the target audience of.
I think it's okay to just give an estimate for typical transaction.
Yeah.
Are you going to put this live?
Yeah, we want. It will be great to put it on, on the emBassy or stuff, on the union.
It's going live.
Yeah, why not? Because it will set some questions.
What's the difference between segwit and non-segwit? Like, can we see a problem?
About 35% in this transaction type. It will be changed. What?
Segwit takes script hash?
No, it's segwit native. So in the advanced, we can add, number of outputs, type of scripts.
This might be worth checking, but I think that 2 input is actually more typical than 1 input. But
Cool. Thank you.
All right.
All right. So, my name is Nico. Michael is my partner, and together during the last 24 hours we've built itSniff. itSniff, it's a funny name, is a tool to determine whether in target communications there is present some Bitcoin-related activity. And we do it using only volume over time of the traffic. We don't read any packets, we don't read any traffic. So what does it actually mean? Every time you use any software that is related to Bitcoin, full node, light node, mining hardware, you create a fingerprint within your network activity. This fingerprint is based on small peaks in activity in few seconds after the block is created. And ask me later if you're interested. It's very hard to eliminate. Introducing delays to the system is very problematic. Encryption doesn't fix that. Compact blocks update didn't fix that. And using proper analysis tools, it can be exploited. It probably is exploited. It for sure will be exploited. Next. So in general, what we do, there is some math mumbo-wumbo inside, but we get some network activity logs which someone recorded. Based on timestamping on the blocks, we get actual block times related to the same time area. Based on actual block times, we predict what kind of network activity we expect as a time series. We calculate something like correlation score, and from this we do a z-score, and we estimate the probability of this specific communications being anyhow related to Bitcoin. Next. Alright, so this is the performance. We actually recorded 24 hours of our own Bitcoin node communications yesterday. And we tried different window size to try and determine how much time do you need to determine with a high confidence threshold that Bitcoin node is present in the communications. So it starts from about zero true positive for 5 minutes, 10 minutes, because in many of these frames there are no blocks present. And we get to about 70% true positive with 0 false positive for about 2 hours windows. Next. So the two use cases that we thought about, the first isn't actually a use case in our opinion, it's a privacy issue. These kind of attacks can be used by ISP or by government to determine whether you have a Bitcoin node or Bitcoin related activity. It can be used retroactively on data recorded right now in next few years. And in Israel it's not forbidden, but suppose in some country it is forbidden to run Bitcoin node, or you for some reason just don't want to share it with the whole world, then it's very problematic. And the second use case is malicious mining detection. There is a lot of Monero mining malware present because it can be mined on CPU. And Bitcoin ASIC miners exploiting cheap electricity by the government facilities, universities, private homes, anything. All right, next. Where are we?
Demo time.
All right, it's demo time. So we actually implemented the whole system. That's our wraparound. You just drop some network log. Maybe you can show a snippet of how network log looks.
So we will begin with a real network log of 1 hour. Right here.
So we're actually analyzing it right now, real time, and 1 hour is kind of a big snippet because it's very unoptimized in terms of computer science. All right, so what you see is the following. The yellow is the ground truth block times, all right? Every block is represented by a yellow peak. White is communications that you have uploaded. Above you can see our confidence level in these communications being related to Bitcoin node activity or mining activity. And you can actually see that a lot of traffic peaks correspond very exactly to the actual block times. So here we have a near 100% probability score. Maybe we have some example of unrelated data.
You are now in the question time, but you can continue. Judges can stop you to ask questions, but just keep in mind that as you continue now, it leaves us less time for questions.
All right, so maybe we should just show one example of something that is unrelated, maybe the YouTube. So we've recorded several small snippets of YouTube communications.
YouTube upload or download?
Watching. So it's mostly just UTP stream going our way, just to show how different it looks and how the confidence levels just drops to very low values.
Maybe you can start questions?
Yeah, you guys are welcome.
So, yeah.
That's YouTube. All right, so you can see there's a lot of constant data streamline going our way. The file represents Bitcoin activity with 36% probability. Everything below 50% probability means that it's worse than noise, actually. So it is less similar to Bitcoin than white noise, just to get the proportions. Yeah, questions, please.
So, okay, so thank you. You're saying that even behind the VPN, this should look similarly, right?
Yeah.
But we were talking before, not necessarily behind Tor, right?
So Tor does some packet padding and packet rearranging. It would be very interesting to check that over longer periods of time, maybe days or weeks. The statistical significance will go up for sure.
Right. And so, would you consider this to be? I said it in English. I mean, would you consider that to be something you can use to actually accuse someone of using Bitcoin? Is that like convincing enough, or because I understand that if we look at YouTube data, it looks completely different. But
yeah, so we have a lot of data to show how this confidence level is achieved. But yeah, pretty much. If you set the threshold high enough, whoever checks you, the ISP, the government, they can be like really sure that if they just come to your house, you've got a Bitcoin node running in.
Right, and that's assuming though that this is the only thing that's running at the same time.
Yeah, so that's assuming you've got a dedicated Bitcoin machine. And connection. Yeah, if you mix traffic, it gets much harder. Once again, with enough time, those small bumps add up and statistical significance will go up. But these results are for a dedicated machine.
Tried analyzing whether there is some other...
Sorry?
Have you tried analyzing the traffic whether there is some other noise, like some other internet usage alongside the node?
Yeah, so I actually tried a little bit adding white noise, just white noise of different levels, and that depends of the mean of the noise, of the distribution of the noise, but shielding your communications with noise packets is for sure the way to go if you want to be protected against this kind of stuff. Just you have to do some math because communications cost money.
You can get it from the satellite instead of external.
Yeah. So yeah, mixing stuff is the way to go.
So that would be your proposal for sort of fixing this. Or do you have any other ideas about it?
Well, you know, Bitcoin communications currently are in clear text. So I think from that to get into proposals of how we deal with statistical analysis, there is quite a gap. But standardizing some kind of packet size, maybe trying to distribute more evenly some sorts of communications, except for blocks propagation, maybe the way to go. Maybe the compact blocks improving proposals will get to the point where these spikes get really small. We're just not there yet. All right, thank you.
Thanks. Thank you.
Alright guys, hi. First of all, I'd like to introduce our team. My name is Pavel Kaminsky. My partner in crime is Boris Zinkevich. He's here. We're the enlightening team. You will hear the word game soon enough. And basically we came here to help with other projects, but we end up creating our own project, which is bringing offline transaction over a Lightning network. So we are both very curious about the Lightning network, and we wanted to get our hands dirty. So this is what we did. So we will use for our demo vending machines. So we have a coffee machine over here. You'll immediately see what we're about to do with that. But the idea is to bring transactions to any device that is not connected to an internet. So in our case, we're using a coffee machine, but it basically can be anything you'd like. And as we all know, there's tons of vending machines, coffee machines, I don't know, maybe the hummus plate, whatever it is. All right, so we'll start with a small demo. So let's suppose it's a very advanced coffee machine, and this is our device. Here we're using a tablet. Excuse me. So we're using a device here. Obviously, this is just for a demo purpose. Just want you to let you know that this device is not currently connected to the internet. So I'm about to turn off the Wi-Fi. You can see I'm reloading the page. It won't load at all. So there's no internet. And let's assume this is our machine, right? So
just someone random walking around, really interested in a bit of coffee, and I found this nice machine. So we're using a screen here, but generally you can just print the barcode on a regular piece of paper. And once I take a regular barcode scanner, I'm gonna scan my device, and it's gonna open the browser for me. And what I'll see there is basically all the stuff this machine can sell, right? So the barcode is specific to each machine. I'll select, let's say, cappuccino, and immediately in communication with the server, it shows me a Lightning invoice, which I'm gonna pay now, hopefully successfully, using Claire. Pam, 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 exciting times, and payment sent. So once I go back to the website, I got a new QR code. This is a voucher for the payment I made, and I'll just show it to my machine. And hopefully, yes. And if it was connected to power, I will be getting coffee now.
So yeah, we should get a coffee, but wait, Boris, what happens if I just copy that barcode and use it all the time?
You will either get a lot of coffee or get an error, because the server actually gives me unique coupons for every time I buy something. So you can just use it, but the machine again is not connected to the next one.
Can you use another coffee machine?
No, it won't work.
Just because
the publicly on the server, and the machine knows its own publicly, so it's only signed by the server, it's only for this machine and it announces.
What does it sign?
It's going to sign a special request. Inside of it is decoded what the person has bought, announced, so you can buy it many times. And the signature verified it's made by a real server.
So we have to keep the nonce,
The server has a full, like we're not showing it here, but the server has a list of all the machines it supports, how much it's sold for every machine, what kind of stuff it's sold.
Oh, yeah, so you're asking the machine, should it,
You know
yeah.
that the nonce was already used in the test.
That's the worst case scenario. The average case, we can like store, like say 10, because we encode the timestamp, so everything above, 10 minutes, it doesn't make sense to store it.
You just need the expired nonce.
Yeah,
for the
absolutely.
next 10 minutes.
Yes. All right, so I'll slowly go over for those of you who are interested in the technical aspect. So what we did here is Boris just came to the machine, he scanned the barcode. This barcode is unique for that machine. Once he opened the, once he scanned the barcode, his phone has opened a connection with our server. Now our server is part of the Lightning network, and it will produce an invoice for Boris to pay. Once Boris pays the invoice through the Lightning, our server pulls the information, it gets notified that it's been paid, and it will produce a special another barcode that will encode all the information, what kind of product should the machine give to Boris, when was it paid, and etc. So this is how it looks like.
5 minutes.
Yeah, we're done?
No, you can continue.
All right.
But 5 minutes passed.
All right, so basically it is just for you to understand. Yeah, I have a marker. We're just looking whether it's pay or not, but we obviously have all the encode here, and we can, expand the UI and make it a bit beautiful. But that's pretty much it. So once Boris showed the special barcode to the machine, it knows it's paid. It just checks the field, and that's pretty much it. Now, technology-wise, we used quite a lot of tech here, since both of us are coding, coming from a different, different environments, but basically we coded the same project twice, apparently, just because we wanted to mess around. Our front end is a React-based, the backend is, my version is on Node and working with the Spark, which Nadav helped me to set up here. Boris' version, which we just showed, is on Ruby and working with LND Lightning Node. Regarding wallets, so we tried it on several wallets. It's basically really doesn't matter which wallet do you use. It basically opens on your mobile device. So regardless of what wallet do you use, it will work. This is the GitHub link. It's also on the spreadsheets if you would like to play with Ruby or Node or whatever it is. So this is us. I'd love to hear any questions if you guys have. Judges, people. Yes?
Have you thought of any real-life use cases for the machine not being connected?
For the machine that's being connected?
Like in what scenario do these things would come about, if any?
So basically, right, so right now, let's say we want to use the scenario of the vending machines. So right now, in order to have a working vending machine, you have it to have a card reader, right? It has to be connected to some kind of network, visas or whatever it is to verify your transaction. It also has to have an internet connection. So basically, you can use the system on any vending machine without no connection at all. So that means I can put a vending machine on top of this roof, and I don't need any permissions or like connecting with Visa or stuff like that. A Burning Man, yeah, that's a good one. Yeah.
So,
yes. Sorry.
So basically, if I'm getting this right, you have the server is just signing a message, some kind of a coupon or token that you can show to the machine, which will create the.
Yeah.
Did you? I mean, that sounds like a very reasonable solution. I'm wondering, just curious, if you considered maybe tinkering with having the offline machine have pre-hashed secrets that could be used as part of the Lightning payment. So you could have, as part of the Lightning payment, the payer gets a pre-image of a secret from the payee, the person being paid to. So you could have like a list of hashes on the offline machine, and then have that on the server as well, which is actually online, and communicate when the payer eventually gets the pre-image. Send it, just show that.
I'm not sure I fully understood.
Yeah.
I think what you're saying is going to be a problem from a machine side, because then you have to set up almost infinite amount of hashes on the machine, somehow refill them to make sure the invoices are still valid for 1,000 people routing or more. And this way, the mechanical part, the tutorial part, you don't touch it all. Once you trust the server, just put the chip inside and the machine is.
There's actually a cryptographic trick that was posted on the Lightning development mailing list using ECDH. It's called difficult one in some way that is like user experience, but it's very similar to what it is. It's very similar with lots of users. Proof of payment that you mentioned is a way that you don't have to keep
One other thing I did want to notice here is obviously for demonstration purposes we used an iPad with a camera, but this is not something that's mandatory. It can be transmitted to the machine via Bluetooth, NFC. Sorry, not NFC, but Wi-Fi, whatever it is, right? So we use the camera, but it's not mandatory. And the idea here is to put some sort of a sensor, such as a camera. Arduino with camera is really, really cheap. It's not like a card reader and you have to talk with Visa. It's just $2 device, that's all.
One comment about on this comment, the thing is working with Lightning Network, but in theory you use spin payment and cloud. So that means you don't want to really connect it somehow to the idea of the whole application might be.
It's not generalized. You can do this for any payment. It's working
Lightning
very
is
similarly actually. The user perspective, very similar.
It's the future.
Yes.
Sure.
Last question because we have that time.
Why don't you have simply connection to the internet and use the regular, I don't know, cryptocurrency transactions?
So why do I need cryptocurrency transaction if I have?
Just have an internet connection and cryptocurrency, any cryptocurrency transaction.
But that's the problem we're solving. We're not interested in using the internet, so we're using for use cases where there's no connection to the internet. If you want to be connected to the internet, I highly discourage you to buy a can of Coke with Bitcoin. Like, it doesn't make sense to go to a blockchain. Use a Lightning or use Visa, right? But the given problem is we don't have internet.
Yeah, what he's saying is, how likely is it that your phone has internet, but your machine doesn't have access at all?
As a vendor of a machine, it's very, very likely because it makes my machine twice. I'm not sure if twice, but it costs, right? So as a vendor, it makes sense to me a lot.
Okay, thanks a lot.
Hello everyone. Okay, so as you know, a good quality of good money is a unit of account. And we know that the price of Bitcoin is very volatile, and people are always checking how many dollars or what other fiat Bitcoin worth right now. So I thought about a platform that anyone can bid a price for anything. It can be something that you can actually purchase, buy, like a vacation in France, but this can be something that is not really available for sale, like having a successful semester in the university. So everyone can tell how much is important to them by giving a price in Satoshi per question. Anyone can submit a question, a price survey to this platform, and I use in this platform a Lightning payments. So if you want to submit a survey, you need to pay in Lightning. I think one of the features that I wanted to add, but I didn't happen to do it in time, is like a public bid, that the highest bid for each 10 minutes gets to be in the main in the main page of the website, so everyone can see your specific survey. Now I will demonstrate how I am adding a new survey to the system and paying with Lightning. This is done using Bitcoin Lightning charge. So I have this page here. I have already the data that I want to save, the description, currently which user is related to this question. And now, as you can see, the data that I get back to from the server includes a link to the checkout page. Now I will pay this. But before I pay, I want to show you that now, as you can see, there is this is still the last question. It was not updated yet. Now, when I will pay, כן, במסך מחובה, כאילו הוא לא הצליח להקרין במסך. בוא נעשה כל זאת.
כן, אפשר קונטרול פלוס מהמחשב, עושה זום במחשב. כן. לא שאתה קליק, כאילו. יכול גם לתת.
So I'm paying the invoice. As you can see, now I paid. And now there will be a new question without data at all. My webbook was down because of network issues, so it didn't work, but it's in development. We have bugs. When it will be deployed, it will be better. So I don't think I will have time for it, but the code is open source, so everyone who wants to make it a real product that can be ready for production, it will be great for the community.
5 minutes. So, if we've seen this succeed, then what we've seen?
What you will see the new question. It is not shown now because the webhook that confirms.
Yeah, understand.
Okay.
We would have seen a new question
Without any data of answers and the new question.
How does the new answer look like?
So this should be also implemented. Not didn't have time for that. I also wanted to make visual graphs and not only table with numbers to be something more interesting. I don't come from a front end so I had issues achieving better version. I used Django, so for the purpose of the hackathon I used SQLite, but it could be any database, and Bootstrap for the UI.
Thanks.
Yeah, okay. This time I'm trying to play with the way we interact with our with the wallet. What I did here, just few hours product, I did it all myself. Just a Bitcoin wallet that is running as a chatbot, which you can just ask it, you can just ask it about a question about your wallet and your balance, or ask it to pay to someone, and it does what you ask. You can just ask for it should get here. It should get me my balance of this wallet. I can just ask him to pay someone, and just everything is done in the background. You can just get the payment and everything as simple as usual. Of course, it's missing lots of basic features. Yeah, but this is what it is. This is what it is. Any questions?
Yeah. So thank you. So I assume that's a custodial wallet, right? The keys.
Huh?
I assume that's a custodial wallet. So the keys are.
The keys are all on the server. Yeah.
Right.
What do you implement the wallet?
It's all Bitcoin.js. The private keys are stored somehow encrypted, but the key is already on the server, so it's not so safe. And yeah, that's intended to keep it's not intended to keep a lot of a lot of money, just to demonstrate or have a simple simple wallet. Yeah. Just Node.js and Telegram SDK for bots, Bitcoin.js for yeah.
How do you fetch information about?
I fetch all the information from Blockstream, I think, and also yeah, utXOs and broadcasting transactions also using Blockstream. Everything really simple.
Okay. Thank you very much.
Yeah.
So, Bitcoin hardware wallets. There's basically two of them. It's Trezor and HD Ledger. Personally, I think neither one of them has a great user experience. I'm not crazy about the fact that you have to plug it into the USB and press tiny buttons on the device. And on top of that, by definition, plugging in anything with your private keys to your computer is not called storage. So I think there should be a somewhat of a revolution in the hardware wallet industry. And I'm here to suggest something that improves both the user experience and the security, and by making it air-gapped, meaning that your private keys don't actually touch the computer that's connected to the internet. What you see here is an Arduino. Okay, it's more of a small programmable board that you can program to do anything you want. I've been thinking about this idea for some time now, and I recently ordered a customized Arduino. This is basically the same device as this, and this will allow you to program whatever it is, whatever hardware that you put on it. So as you will see here in the center, it might not be easily visible, but there's a RGB sensor. It's a light sensor that can detect color, and around the edges you see 12 LEDs, and you can basically program this to do anything you want. Now, I recently received this. I ordered this from China, and they kind of did a small mess up with the LEDs, so this is not actually working, so I was not able to use this for this demo, except for the light sensor in the middle. So we're, like, for the sake of the hackathon, we went back to basics and did the old-fashioned style Arduino board. Now the idea is that what you're going to do is you're going to open an app on your phone, and you're going to be requested to input your from address, the to address, and the amount. The phone will then create an unsigned transaction on the device, and it will then ask you to place the chip in such a way that the light sensor covers the front of the screen, and one of the LEDs covers the front-facing camera, so something like this. Okay? Now what the screen will do then, it will flash the screen, it will flash the unsigned transaction in such a way that this can read those flashes and decode back into the unsigned transaction. The private key of your Bitcoin address is on this device, and it will sign the transaction and flash it through the LED in the front to the front-facing camera on the phone. The phone will receive the signed transaction and be able to push it to the network. Before I talk more about what the advantages of this are, let's do a small demo. You see, there's 5 steps to this. You create a transaction on the online device. You link the transaction to the offline device. The offline device signs the transaction. The offline device links back to the signed transaction, and the online device pushes the transaction. So we've tried to cover all those 5 steps. We've managed to do several of those steps. This thing actually was working with the sensor in such a way that we could actually have an HTML page, which you can see here. Change these colors. What we did is we defined a starting sequence for this thing to start reading inputs. It's blue, red, yellow, green, red, and then it starts blinking. Sadly, for this moment, we could this thing, once again, the Chinese didn't do a very good job, and it kind of stopped working at a certain point. So we're not going to do that, but we are going to show you how we can blink back from this LED to this phone the signed transaction. Oh, sorry. So
5 minutes.
Okay, so we're gonna refresh this page. Okay, and then I'm gonna click this Arduino here, and it will start flashing the light. And I'm gonna press it. Oh, it's not running. סליחה, Okay, and we're going to place this right in front of the camera. It's going to start blinking. The camera, as you can see, the ones and zeros are the encoded signed transaction in binary. And once this is done, it should take another 5 or 10 seconds. Okay, we have. Okay, let's do this again. Okay, so we're going to do this again. The idea is that you don't want to move your hand too much. This is currently running at around 10 bits per second. We managed to find another piece of code that significantly improved the speeds to something like 600 bits per second, but that required, no, do it again. No, you try. You see what's happening, it's sending 160 bits right now, and even if it misses one, then it's not going to show a kind of confirmation box, so we're going to try again to get it to okay, it does 5 seconds of.
About the size of a real transaction?
This is a real transaction. The reason, this is an Ethereum transaction. The reason we use Ethereum and not Bitcoin for this is because we could find a very short Bitcoin transaction. As you can see, it's 160 bytes. Okay, there we go. Do you see this on the iPad? Oh no, just a minute. Sorry, guys. Okay, is this back on here? Well, it's not, but what you can see here, how are we going to do this? What you can see on this page right now is since those 160 characters were transferred correctly, do you want to transfer to 0.0 whatever, the address that you're actually sending to? We can actually check the values that are currently in that address. We see that there's 482 and 460, and then we're going to ask to transfer. We're going to wait about 15 seconds for the Ethereum block hash for one Ethereum block hash, and then let's refresh this, 482 and 460. We're going to refresh the values, and you know, we can also see them here. Yes. Let's refresh this. Last transaction 2 hours 45 minutes ago. No, let's do transfer again. No. There we go, 470, let's refresh this. Okay, so 2 hours 15 minutes ago, 33 seconds ago, there's just been another transaction, and that's the to and from, so the 0.47, let's refresh that, and that should be the 43 seconds ago, it was already auto refreshed. So what we've really done is we've really air gapped the private keys from the computer, which does not really exist today in the hardware wallet, Bitcoin wallet. Personally, I feel that it's, as I said, it's a bad user experience, and it's not good security. It's more of a, I mean, the Trezors and the hardware wallets, they are more of a convenience device, in my opinion, than a security device, which is kind of against the whole, you know, Bitcoin philosophy. So I think something like this could improve the user experience and significantly the security as well.
How do this compare with the QR?
Okay, good question. The reason I'm doing this super low tech is because this would be very cheap to manufacture. The components of this on this are about $8. for wholesale, for retail amounts, if you do this in the 1,000, you could significantly drop the price. I'm thinking if you could manufacture this for under $10, you could sell this for significantly less than Trezors, and so on, which are about $100.
Security and stream on the device itself, see the
right.
you're going to send it also.
Okay, so the way so the screen obviously would make the device more expensive, but being able to read a QR would make the device significantly more expensive, so it's a completely different device. But what you could do on this is when you sign the transaction, you transfer it with another piece of another password that the user has chosen before, and you can only decrypt the signed transaction with that password. So if you want to have another layer of security where you know that if somebody steals this coin that they cannot push transaction without your permission, you can add another password to it that the user will have to enter. Another, if you really want to take it far, you can, instead of having the screen flash the unsigned transaction, you can have the screen flash the unsigned transaction onto a video file and on your phone, which you could then verify on another device that is actually linking the right thing that you want to link, and only then meet it up, pair it up with the phone.
Last question.
You're saying it's AirTap, but it also gets fed this information just through blinking instead of through a cable. What makes it more secure?
Okay, as I said, like if you really want to be sure that this video, flashes are doing what they're supposed to be doing, then you can do it with a video. With a cable, there's no way you can see because you cannot separate from when the cable sends it to when the device receives it. Here you can separate when the moment from when the device signs the blinks to when the transaction actually gets sent or signed and sent.
Thank you.
Okay, so my name is Alon. I've built this kind of as a nice game or a way to gamify block explorers. So in a second we'll have the opportunity to all play together. Probably Udi will play because he's the closest. But just a bit of a background before we start. It's a Space Invaders game, but all the data points are from the recent block. So we'll have coins in different sizes. They represent different fees in the recent block. We have the block reward. Look out for that. It's a really good one. 12.5 bitcoins for now. Other than that, we have the block height, the weight of the block, so the amount of actual space or blocks or coins that we'll have depends on the size of the block. So if it's a small block, we won't have a lot of enemies to avoid, and if it's a heavy one, then we will. And for some reason, there haven't been blocks for 18 minutes, so maybe we'll have the experience of seeing a block arrive. We only have 5 minutes. Yeah, on average, it will happen in 10 minutes, but we don't know. So Udi, space to shoot, arrows to move.
Let's do it.
You can press the click to start when you want. Just focus on the screen for a second. Yeah, okay. רבע? שיצא לי מסך מלא. They're killing me, go on. F11. Sorry, F11. F11, escape the, not 12, the one beside it. And refresh the page, just so we're...
Somehow all the pressure is on me at this time.
You'll need to answer all the questions after.
How many seconds ago? What is...
Nadav is debugging your game.
Come on.
This is really game.
So as you see, it was a very small block, so Udi will have a good, easy time, maybe. Maybe not. So every coin that Udi tries to hit, you'll see the fee. So you can see all the fees amount up there, but actually if he'll hit the coin base, he'll get most of the fees. Ooh, nice, 12.5 Bitcoin. Okay, now if there will be another block, so we haven't had a block for a while, so we get the same setup, more or less. And the idea is that anyone that plays this game, it's like online, you can play it on your phone now if you want, and you get the same setup. So the same block, given the same block, you'll get the same game, and you'll never get the same game twice because, like, after the block passes. And there's also the difficulty is set, so it reads the block hash. So in like if you play it in like 2 years, it'll be like really, really tough. So and yeah, no, well, maybe we'll get another block and we'll get some more info. Yeah, and yeah, that's kind of cool because you see that that's the only reason to actually mine blocks. There's not a lot of fees. We still have a very high subsidy ratio, but Udi is getting them, so it's fine.
So the green things is the fees?
So yeah, each coin here represents one of the layers of the. So it's like binned different layers in the recent block. So these are actual fees from the just diffing between the V in and V out. Someone wants to mine a block, so we get some more interesting things going on. 22 minutes.
Give me 10 minutes.
Yeah, that's a problem. It doesn't matter, it'll take 10 minutes. Yeah, so the idea is to have this running in the Bitcoin emBassy, to have it like as a screensaver, and also in Nadav you can also play if you want, maybe beat it. Yeah, and maybe have like a joystick there that people can play, and you can just, we could easily open up 2 screens side by side and play one against the other, but we're not going to do that because you had problems with the. Question? So if you just Manny does that at the beginning. So I'm like more researcher, back end, like maybe. I don't do front end, and this is my first experience, and that helped me out quite a lot.
Better than mine.
No, it's mostly a framework that I use, but yeah. So I wanted each new block to arrive and have many dance. The honey badger, but we don't have another block, so we won't see it. But we could just restart it and put many on. And think. Oh, we just lost. Yeah, Bitcoin's dead.
Text stack or whatever. It's Nadav's. Wait, still playing in the background. Yeah, so once if you remove this picture, then we can just have this running in the background and reporting on new blocks, and it's a nicer way to report them. So it has like you guys.
Thanks.
Okay, hi. So thank you for coming. So before we get to the issue of the prizes, I want to give a quick thanks again to our sponsors and everyone who helped us here. So our sponsors are Hippo Swiss, Fluger Ventures, Toylab, Zisman Aaroni Gair, and eFrontier. They're also the supporting organizations that help us, which are the Israeli Bitcoin Association and Bits of Gold. So, thank you. And also thank you everyone who came and participated, and thank you everyone who just came here to hang around with us too. All the projects that we had to think through were great. This is why we took a little longer than we planned to consider them. We actually love them all. And we picked 2 + 1 projects. The first one is not one of the 2 official winners, but it's a bounty that we wanted to give from the Bitcoin emBassy. for a project that we're going to use physically in the Bitcoin embassy. And there were a few options. We decided to go with the Space Invaders blocks games. Thank you, thank you.
Now I wanted to play, I send the link on the Telegram group. I'll post it on the
There's a prize of 10 million Satoshis.
Oh yeah.
The bounty of 10 million Satoshis. So, to the second place. So, well, for the second place, for 30 million Satoshis, yeah, that's a lot. We chose to go with itSniff. itSniff, where's itSniff? And yeah, we really liked your work. We hope that you use the bounty to keep polishing it and maybe even get a paper ready and maybe have some ideas for it to keep it up. So thanks a lot. And for the first place, the first winner for 70 million Satoshis. Enlightening. Yeah, and that's, I think this is pretty much it. So thank you everyone for coming. Thanks everyone who participated. Thanks everyone who helped us in this event and helped building all of the great projects we had here. I really hope to see all of them continuing, you know, development over the 24 hours that we had here. That's it. Thank you.